Yeah, so I'm going to show three things. One is to how to create a complicated workflow, for narrow studies, and the second I'm going to show how to analyze the simulation results, and finally maybe show some functionality, visualizer functionality of RN flow. So we totally based on the roadmap of the neural work. So there are going to be 35 data sets we're going to upload. So we can upload it first. Yeah, just click here. We can upload every data that we can upload. I don't want to repeat it. So yeah, I already upload all the data in the history. So I just switch to the history. Yeah, so this concluded all the data that I upload. So, oh, sorry. So that's all the data. We need to check the data. We can use some standard load visualization tools to examine the data. For example, we can use this climate scenario anomaly to analyze the future climate scenario. For example, we want to see how the future climate change. So for example, we want to see this scenario compared to the baseline. So we just make it run. This will be very quick. Yeah, so just a moment.
So you're just analyzing the climate data that you've already uploaded.
That's right. That's right. Okay, results is ready. So this is the a simple analyzing of the climate data, and the user can analyze their climate scenario they upload, and they also can show different climate variables and the different scenarios, and also absolute of climate variables, and also the relative change. And then after all the data uploaded and the data have been checked, we can use the we can create our own workflow. So this is a very complicated workflow that include 12 scenarios. So each line represent either a scenario of climate or management scenarios. Yeah. So in order to distinguish the difference, so we annotate each one. For example, for this one, we just represent it as history and the current. And this one is the climate scenario of IIFA. So each one I allocate so that we can make it run. So this is very important step because users have to select the data from their history. So before, but we have some annotation history and the current to guide the user select the right data they want to use. So before you make the run, you need to make sure that every data select is right. So this is very important. Otherwise, there are some errors in the final results. So after all the data have been identified, so we can click the run button and make it to a new history. This takes some time. The running takes some time, so I'm not going to show you how to select the right data. Just show the final results. So this is the final results over there. So that's all the results is over here. There's more than less than 16 histories. The final one is the results. So it show the 12 scenarios of different climate and different management. So the left one is the 2007 results for more than 100 sites in Europe, and the red one is the current, and the blue are the future climate without adaptation, and the right fives are future with adaptation. If we don't like this analysis, we can do some other kind of analysis, such as to say some different variables. We can select different variables and also select different plot types, for example, CDF. So we can also show the results, different. Okay, it's over there. And also we can do some complicated combining analyzing by use some combining AcmoOutput outputs. For example, once we have all the results, we can do some correlation analysis. For example, we just pick one, AcmoOutput outputs. We can do some basic analyzing. For example, we want to do some correlation analyzing between precipitation and simulated yield. Then we can save and click and to show how the relationship between changed after the climate change. So this one is showing the relationship, but maybe the correlation is not so high due to some problems. So we can also select a different grouping method. Maybe it's caused by weather zone. So so there. So for different weather, so they have different type of correlations. And this is just for baseline scenarios. If we want to see the changes for the future, we can select different. Maybe we can select different outputs. So maybe this is a future scenario. So we can also do the same thing to show their difference. So there's a bunch of functionality for analyzing. So we can say for future climate, the results is totally different from the it's slightly different from the history from the baseline. So that's the some basic idea of the complicated workflow. I think that's please give any suggestions and comments.
Can you show what other variables they can use to analyze the outputs with?
Yeah, there's a lot of outputs variables we can choose. Currently, we choose such those variables such as observed yield and biomass and simulated variables. And one important character is that we can do some correlation analysis between the climate and with the simulated outputs. For example, for precipitation and for temperature and for maximum temperature, we also can do this kind of correlation analyzing. So we still can add more variables if we have this kind of results from different models. So that should be more powerful.
Okay, that's great. We only have a few minutes left, but are there any questions?
Hey, I have a comment. I wanted to say.
Wei Xiong, can you do two different crop models on the same plot for that probability?
So the question was, can you do the same probability graph using data from two different crop models?
Yes, Currently, we just only choose to that. Later we will incorporate FSM as well, and so we can compare the difference between two different models. So
the idea is that you have to be able to combine the ACMO files together first and send it to this tool, and then you can group in different ways, including by crop model.
That's right.
Okay.
Any other questions?
On one of the previous screen, I saw the steps 38, 39, 40. What are this? Is just processing the data, or?
Those are just the steps in chronological order that the workflow did the computations. It's assigned by galaxy.
Okay, thank you.
Yes, that's right.
Can you hear me here? This is Alex.
Yeah, the numbers are just assigned in order to make orderings. Yeah, they're not. The numbers aren't.
Yeah. Hi, Alex.
Hey, so could you show me how the get data button works?
Data button. Oops.
The get data. So actually, he did not use the get data. He used another upload tool, that little arrow at the top. But under get data, there are various different options for getting data from different sources.
But it's more about downloading data that I'm interested in, because no matter how many visualizations you produce, somebody might want something a little bit different. So how do they get the raw outputs from the system?
You can just go to
everything can be downloaded to your local system.
You just click the history steps, and here there is a download button. You can download.
Great. It's good to see.
And any steps could be downloaded.
Yeah, and I think if I can, do you mind if I steal the presenter from you, Wei, or are you done?
I'm done.
Yeah, go ahead and take it.
Okay. I just wanted to show one other thing with get data that I think is really cool, and we didn't get really a chance to show it. But one of the most powerful features is the ability to connect to other data archives that are available, and to do it in ways that people are familiar with. So this is the DayMet browser that I don't know if people are familiar with it, but if you actually go to their website and you go to the browser window, it looks exactly the same as the version that we have. So we've worked with them to add just a little bit of extra code to their server, so that to add the ability to send data directly into a FACEIT workflow. So you can choose a point just like you normally would in DayMet. You can choose which variables you want. You can choose which years of data you want. And then instead of pushing get data to download, you push a button to send the data actually into your FACEIT, and it shows up here in your FACEIT window. And so here I've already downloaded one earlier. You can view it, and it looks just like the DayMet data you're familiar with, and you can then use it in workflows as well. The FACEIT understands the data format and how to translate it back and forth with other popular weather data formats. So you can actually use this data downloaded directly from DayMet to run simulations. We've also made a ton of data available through Globus Online from the GGCMI project. So we've made both AgCFSR and AgMerit data are available on a point-by-point basis. And we made currently all the data basically available from the EasyMap Fast Track and from the GGCMI is all available on a point-by-point basis. You just put in your latitude and longitude and execute it, and it comes currently in this PSIMS format, which is understood by the data set. We've also made a ton of soil data available in a similar way. So we have data sets from Africa. You'll recognize these from the USAID Soils project that we did. This is the Harvest Choice 3K and 27 HC3 data sets, and a few other, and we're adding a bunch more of these. So basically, we've tried to create, everything from and then, of course, here, this is one you'll recognize, which is the AgMet browser. So you can actually go directly to the AgMet browser, and you can actually zoom in on your point and identify data in your normal way that you're familiar with, and download data directly into Galaxy. So basically, it's like I said, it's because there's a diverse array of data, it's a diverse community, all kinds of data types. So we're creating a diverse set of tools for accessing data in basically any way you can imagine. And I haven't even talked about APIs. We're also, of course, integrating sort of data APIs so that you can actually grab data directly from remote databases, directly in workflows, without even having to browse and do anything at all.
Any comments? One of the things we want to get out of this is your suggestions for improvement. So this is still in production. It's still under development. So if there are, if you see any glaring holes or problems or, things that we could do in a little bit better way, please let us know. The other thing is, if you want to try it out, we will be able to get you access to Galaxy. It's under development. We haven't worked all the bugs out of it, but one of the ways that we find those bugs is for having people use it. So that's a possibility too if you're interested in being a beta tester.
Yep, definitely. We're certainly happy to get people online and get them working in the platform in a sort of a controlled way. As Cheryl said, it's quite a prototype, but we think we've built out the level where there's enough features now that people can really start to use it and play around and break things and teach us a lot more about the platform.